In this video, I'm going to look at some more compound interest problems. This will be on, say, applications and extensions. So we'll look at the first one. How long will it take for an investment to double if it earns 10% compounded continuously? Okay, so how long will it take to double at that interest rate if it's compounded continuously? Okay, we looked at the formula for continuous compounding. That's this one right here. A is equal to P e to the RT, where R is the interest rate and T is the time in years. So basically we want to invest P, and with that we want that to double. Find out the time it'll take for that to double. So here's another way to write it. We don't even have to know what P is. We just say P on this side invested, and we want the A, or the future value, to be 2P. So basically what happens here is set up your formula. We want to solve for T. The P's will cancel here. And that leaves me with 2 is equal to E to the 0.10T. Okay, replacing the R by 0.10. And of course we're solving for T. Okay, so now from here we just take the natural log of both sides. And we want to choose natural log because we're using the base E, so it makes it easier. So this would be taking the natural log of both sides. Get ln of 2. And then when you take the natural log of both sides, because it's the base here is E, and the base of the log is E. Remember, this is E. We don't put it, it's understood. So basically on the right side, that just gives me 0.10. T. Okay, so when I solve for T, I divide both sides by 0.10. So T then will equal to ln of 2, or natural log of 2, divided by 0.10. Okay. So you can do that on your calculator. I use my graphing calculator here, and it would just be natural log of 2, parentheses, and then divide by 0.10, or 0.1, it's the same thing. Hit enter. And we get 6.93147 and so on. So we can round that off to say 6.93 or 6.9. Either way, depending on what they tell you. And that's in years. So if you invest any amount P, no matter what it is, if you invest it at 10% compounded continuously in 6.9 or 6.93 years, it will double. Okay, on the next one, what will a $90,000 home cost in 5 years from now if the price of appreciation for the homes over that period averages 3% compounded annually? Basically like an inflation. It's going to cost you more in 5 years than it does now because of inflation. So basically this just involves almost the same thing as just finding compound interest of a certain investment. In this case it's 90,000. And here's your formula. Okay, so consider P the value of the house now, which is 90,000. Interest rate is 3% compounded annually. So using the graphing calculator then, we're just finding this part right here. And what we get for A will be the value of the house in 5 years. So we just go 90,000 and then parentheses. This will be 1 plus, and then the R divided by 1 in this case, it's still going to say 3%. Write it as a decimal, 0.03. And then the exponent here is the number of periods. Well, it's compounded annually, so it's 1 period per year, and there's 5 years. So the exponent here is 5. Hit enter. And we get 104,335 if you round off to the nearest dollar, or you can leave it as 0.67 cents if you round off to the nearest cent. So either way, 104,334.67, rounding off to the nearest cent. Do this. Number 3. John will be buying a used car for $15,000 in 3 years. Okay, so that's 3 years. How much money should he ask his parents for now, so that if he invests at 3% compounded continuously, he will have enough to buy the car? So consider $15,000 the future value, and basically we're looking for the present value. So the setup then is compounded continuously, so we're using this formula right here, A equal P, E to the RT. So the setup would be something like this. We're looking for the present value, so this will be P, E, and this is 5% compounded continuously, so the exponent here, there, R is equal to 0.05, and it's for 3 years. So this is 0.05 times 3, or 0.15 is the exponent. And we want this to equal to a future value of $15,000, because that's what he's going to pay for in 3 years. That's what he pays for the car in 3 years, so this is $15,000. If we sell this for P, we get P then will equal to 15,000. And that's going to be divided by e to the 0.15, multiplying the 3 and the 0.05. Okay, so now we can do the rest in the calculator. So we'll get a 15,000 divided by, okay, the exponential will be second here, and then this will be 0.15. Hit enter, and the present value then is going to be 12,910.62 cents. So 12,910.62 cents, rounded out to the nearest cent. That's what he would have to invest now at that interest rate. And in 3 years, he would have the $15,000 that's needed to buy the car. Okay, thanks for watching. We'll see you next time.